Thanks all for coming out. Today I'm going to tell you about the past, present, and future from the data platform we built at Sanoma. Is there more coming, or is it lost? Ah, wait a sec then. But they're all coming here, right? That's, yeah. Okay, that's good. So something about me. I'm manager for all common components within Sanoma. We work with these distributed teams building our front-end products. And there's obviously a lot of in common or common components they use. And my teams are responsible for building those. And one of those common components is like the big data platform, which we then provide to various business units. Sanoma is a publishing company, publishing magazines, consumer magazines, and in Finland the two largest newspapers, the Helsingin Sanomat and the Ilta-Sanomat. We have 5 television stations, 3 in Finland, oh, actually more, and 3 and recently 4 in the Netherlands. We have about 200 websites related to those magazines and those newspapers, but also separate ones. For instance, we have the largest news site in the Netherlands, nu.nl. I don't know who's from the Netherlands, but and we have about 100 mobile applications, also one of the biggest in the Netherlands and Finland. So these assets generate a lot of data, and we use big data for processing that. But when we started this, we didn't have a really big BI heritage. We use reporting from like the source systems, which provide usually aggregates, and then combine them in Excel, and use that for the reporting. And in the technical teams around end of 2008, beginning of 2009, we started experimenting with Hadoop. Looked really promising. Then later in 2009, we discovered Hive. Well, this is starting to get really interesting because this is like an interface that also other people can use. But we still didn't have like this use case to build and to combine this data. But all of a sudden, there was this demand for aggregating or like combining multiple big multi-gigabyte data sets and combining that into a real-time dashboard. So we thought, well, this is now finally our chance. We'll build this with Hadoop, and with those services, we found that to really make it scale, we had to provide some layer of self-service. But we were not there back then. And well, for the people from the Netherlands, this is also what we consider self-service. And if you look at self-service, there's like multiple levels. There's like the real information workers on the left side, and on the right hand side, there's like more of the consumers that usually solved by traditional BI. And on the left, the full agility, working on local or specially defined environments, to like the really centralized development on the right. Excel to static reporting. And the area we want to focus on was more of this departmental level. We didn't want to go all the way and publish like our financial numbers, and we didn't want to cater for like this one business analyst that want to do something. So it had to be somewhat broader. So from that sense, if you look to like the chain, we thought initially we'll just focus on like the last bit, get all the data there in like a data mart or so, and then provide a self-service BI environment on which people then can consume the data. So great. We choose ClickView as the BI tool, so the really front end, which is in-memory analytics tool, which means the data set you want to analyze or visualize had to fit into memory. So we had Hadoop and Hive to then really make the aggregate level that could then fit into ClickView into memory. So life was great. We only missed one thing, and that was the glue. How to piece this together. Typically pick like a ETL tool for that, for extracting the data, transforming it, and then loading it. So we picked one. We picked this one. Familiar to anyone? Yeah. Pentao. Yeah, you're right. You're right. I promised another vendor to make it specific because they said we could have solved that back in 2010. Well, I don't think so. But life is good. Simple flow, getting the data on. So the first thing, everything worked. It was like back in 2010, one of the only ETL tools that had like a connector to Hadoop. So that was great. But then the flow started to be a bit more complicated, and we had to dive deeper in these components and start debugging, and it became a bit harder. And then came the biggest problem, that a typical data source for us is like 10,000 or 50,000 files of 10 till 100 megabytes that are on a FTP location. So you have to load them. What the ETL tool does is like creates all these separate steps for that and start loading in sequence. So you want to parallelize that to get a bit more speed. But then all of a sudden, your ETL flow starts looking like this. And then really rapidly, it starts to become unmanageable because then some genius decides to switch like the compression, and you have to add like the, 15 boxes again with the compression, or add a field. So you start writing a code generator for your ETL tool, and then, yeah, you're completely wrong. So you're adding boxes with like shell to do it. And then again, yeah, why do you have this ETL tool? So this turned out to be an epic fail. But still, the tools we had in place were not that bad. Hadoop really provided some interesting features. And the team, back then it was me and a colleague, were solving a lot of reporting problems with the tools we had in place. It was not perfect, but for other use cases it worked. So what we then needed was like a reset, because it was 2011 starting to 2012, and the number of sources started growing, the demand started to grow, and yeah, we couldn't fulfill that because we were the bottleneck. So we had no self-service left, so we had to reset. And then there was a Hadoop Meetup in Utrecht in the Netherlands, and this guy came. Does anyone recognize this one? No, he's famous in the Hadoop community. Yeah. He's a real pig Yeah, you're right, Niels. It's Russell Journey, and he wrote a book, Agile Data. If you have not read it, you should do. And he says, well, from that entire ETL chain, you should go Agile all the way. Everyone should be able to do everything. Your business analyst should be able to extract the source. Your data scientist should be able to extract the source, and should all collaborate on this platform. So he thought, well, sounds really cool, but maybe a bridge too far. But we really bought into the idea that the level should not be at the reporting side, should not be on like the data mart side, but should be much further down the chain to really enable this self-service. So we needed some new glue. We needed something to really piece this together and to be really agile in bringing forward new data sources and new information from that. So if you then boil down the functionalities you need some processing, you need something to schedule that, you need something to control the data quality, the data lineage, you need something for versioning, and yeah, annotation or documentation. You need to describe what you've built. So we looked at the various options. We did a spike, and we looked into two other ETL tools. We looked into Uzi, and we looked into scripting, so Bash and Python. And we had like this use case that was pretty common for us, and it took 3 days to implement with the ETL tools. It took 1 day to build it with Oozie. It took 1 hour to build it with Bash, and it took 2 hours to build it with Python. After that, are there any Oozie users here or committers? Because then I'm going to offend you. Sorry, I'm going to offend you. After that, one of the team members described Oozie of being Hindi for elephant shit. So we were back to Bash. We really liked the expressiveness of it and of the way it interacted with the cluster. So this was the basic script, getting stuff from the FTP location, or at least getting the file listing, getting the differences, and then the loop for getting like the file. So it's iterating this loop, and I mentioned it was 15,000 files on the FTP location. So it's iterating that, and then doing 3 Hadoop commands. Well, life is still good, except these all spin up a JVM separately, which adds like the 150 millisecond, 200 millisecond delay of the JVM starting. So this still didn't work on scale. So back to Python then. But Python didn't give us the connectivity to Hadoop. So we use this variant of Python. It's called Jython. It's still Python, gives you the language constructs of Python, but runs in the JVM and gives you access to all Java libraries and all Hadoop libraries. So you can call all functions, so all HDFS functions, and this only takes 200 milliseconds at the beginning to initiate the JVM, and then runs really rapidly and gives you both the expressiveness of Python and the direct control of Java for controlling. And this is what we built our platform with. So we took Jython for the processing. We then needed something for scheduling. Yeah, we built some of the transformations in Java, so we already had Jenkins for building it. And we figured, well, Jenkins contains a lot of the properties we need. It contains scheduling, it has some dependency management, it has reporting, it has notification, it has an API, it can scale to multiple nodes. So processing, Bash and Jython, scheduling Jenkins, versioning. Well, we're already versioning everything in Mercurial, and commenting. Yeah, we commenting the code. The data quality and the data lineage. Yeah, we didn't get out of the box, but when we look back at the ETL tools, with all the hacks we had to make them perform, we also lost like the capabilities around that from the ETL tool. So what kind of processes do we build around this? So we try to make independent steps, so we don't glue everything together, because then if something fails, it's really hard to rerun. So we have these like inboxes from the source. Everything goes to HDFS. From there, we move it to Hive staging, and from there we do a copy to the final structure in Hive, because that's the end product we're delivering to the business users. So Jenkins scheduling the call and getting the code from Mercurial, executing it, moving the data to Hadoop, then doing the transformation in place, creating the Hive structure, and then finally loading the aggregate to Hadoop. So this is what we call the out-of-order jobs. So it gives you the way to really have these independent steps. But you do need like this data store that you can roll back. So that's where we use the Hive partitions for. So we partition every day, all the data on day. So if something went wrong on a day, we just remove it, place all the files into the staging directory again, and it gets automatically rerun and automatically merged into the final data warehouse. So that gives us a way to provide the self-service. So we're the sources come in, we put it in its original form in on the cluster, so we always keep like the original we acquired. From that, we create a normalized data structure in Hive. That's what we expose to the business analyst. The first part, so the source data, is already directly used by the data analyst. So from an agility point of view, usually in one sprint you can do the extract. Usually you can do it in an hour. But in one sprint you can do the extract. Immediately the data scientist can start working on the data we provide on the platform. In the next sprint, you can provide the normalized data structure, and we provide it in like the system, in the source system structure. So we don't model the data; we just make sure like all the dates are formatted correctly, and the physical structure is the same. What then the business analysts do is from those data sets create, data marts, or how you would call it, views on the data. Which they then use in like upstream reporting, or in connections to SES or to ClickView. So this is the interface, you and Hive. This is what we expose to the business analysts. ClickView then for the reporting. Our studio for some of the data science workloads. It's shifting more and more to really run on the cluster using Scalding. Jenkins for the scheduling. How do we piece that together? From the sources, Jenkins to Hadoop, where then Hive and you are for like the ad hoc queries. We created like this plugin button into you, which says export to ClickView. If you hit that, then the query you're running is exported directly to our ClickView environment, where you can load it from there. Then business analysts can like schedule the jobs themselves. So they just copy paste the query and put it in a file that's then executed automatically to get to ClickView, and we export some of the data to other systems. Now moving more into to real time, we have our own collecting infrastructure for collecting these real-time events. And we use Kafka and Storm for that. So it adds this extra layer. Well, nowadays this would you call like the Lambda architecture, with like the speed layer at the bottom and our batch layer at the top, which immediately brings forward like the challenges we're having with like code duplication. But that's something for another for the next stage to solve. We're running this platform as like a best effort platform. So we provide this service to the business in a best effort way. There's no SLAs on this, because, well, we could not afford to run 25, 40 nodes as managed hosting at our provider. So we had to use co-location with like less availability. But how did we mitigate that issue of having this best effort environment? Which, if it goes down on Friday 5:01, it's down until Monday 7 o'clock. So we have two data centers in the Netherlands. High availability zones for some of them, but the big data platform is separate. So we provide the batch processing and the storage on co-location with best effort, and we provide like all the user-facing services in the high availability environment. So there's the collecting, there's the Kafka and the Storm. So all the real-time components are there. And also, if we process stuff like recommendations, it's fed back to the production environment, to the high availability environment, and then served. So services on the right-hand side have to be able to keep 3 days of data on their service. And service the other way around, they should be able to work with 3 days of stale data. So it should not flush its cache when no data comes in and serve empty recommendations. Yeah, obviously only for the systems that can really do that. Otherwise, they should have find another way to so how does it look now? We move back in this chain. So we only provide the source extraction and then the transformation to this common format, and the rest is self-service or is handled by other departments. We solved this by Python and Jenkins, added Kafka and Storm, and now recently moved to Yarn. That's a story in itself, because we did this in January and all the beautiful stuff we built came crashing down on us. So there goes your best effort promise, because yeah. And what turned out is that with Go, and some of this is related to Yarn, but a lot of it is related to CDH. We're running CDH, and that provided some additional complexity. And what turned out was that like functional testing, if everything works on your new environment, is not enough. You should really stress test it as well, which is always a hard thing to do with your big data infrastructure, because, well, we're like shown, hosted on premise. We don't have like a copy of it. And what turned out that all jobs function fine, but if you combine the full workload, it's not only giving you the deadlocks, but giving you also a lot of locking issues in Hive, which just don't turn up when you do the unit testing and the functional testing. And what turned out is you have to take some time into account to really tune all the parameters for Yarn. It is really different than running a production environment on just MapReduce. We had a consultancy company helping us with the migration. So yeah, they should have provided like the real insights and what knobs to turn, but still it took like almost a week to really get the cluster back to the performance we had before migration. So if you're doing this or planning to do this on a production environment, really plan carefully. Some CDH 4 to 5 specific issues. We use Hive CLI a lot because that's like underwater what's scheduling all these queries. That had really weird compatibility issues, so we had to move that to Beeline, and the before mentioned Hive locking was really an issue. Hive now locks the table while you do a select into, which is like our main way of merging the data. So yeah, we had to find a new way of doing that. So we're now making a copy of the structure of the table, insert into that, and do an in-place move, which mitigates that problem. But still, yeah, it took some re-engineering to get that up and running. So what use cases do we run on this, or our users run on this? Mainly combining the various data sources. So you can imagine we have a lot of advertising data, a lot of web analytics data, a lot of targeting data, and you want to combine that. So you want to combine user profiles with like web analytics data. How do people that like cars navigate the site compared to people that like holiday? A/B testing also coming from that. Various ad optimization workloads we're running, recommendations, and also some search optimizations where based on the analytics we change parameters on the search results. So our current state of the platform, main workload around the reporting. We're now like the standard data platform within Sanoma. 250 daily users of the ClickView environment, like 40 analysts and data scientists working on the cluster on a daily basis, and about 400 tables in Hive, resulting from the 40 watt source systems. The team, there's the platform team. We provide like the platform and this self-service layer. It's 4 people, it's 1 product owner, 3 developers. Product owner and a developer is here, so if you want to talk to them, come to me and I'll get you into contact. Don't recruit them, please. I'm really fond of them. And we work closely with like people from other teams, like the data science team that run a lot of their workload on the cluster. ClickView as a separate application manager, like a system and data architect. Current cluster, 55 nodes, if they're still all up. Otherwise, we have 54, which then will reduce the storage amount by about 16 terabytes. We run about 3,000 jobs a day, and we have a hybrid environment of nodes, single core and or single CPU and dual CPU machines. Data disks depend 2 to 4 terabytes and about 24 to 32 gigs of RAM. That also posed a big problem in the move to Yarn. You should really bring down the groups you're having to get some efficiency there. We had too much combination, so after the migration, actually the product owner went back to the data center to still make some changes to the hardware to make it make smaller groups of or bigger groups, less groups of machines for Yarn. So what challenges are we still facing? Number 1, security, because we feel security should always be our first priority, and increasing the SLAs. So we are best effort now, but the usage is every day increasing, and business now say, well, yeah, we're running this really important workloads on your cluster. Please give us a higher availability or some more guarantees. Integration with other BI environments. We still run a big SaaS and a BO environment. Connectivity with Hadoop is not perfect. Data goes back and forth via data dumps, but yeah, it's much better to have like a direct connection. Improving the self-service even further. Data quality always an issue, and the code reuse. Because what I said, yeah, we have somewhat of what you would call a Lambda architecture, but one part is ran in Jython, one part is ran in Java. So we don't have that much code reuse there. So that's something we in the future want to improve further. Yeah, so like I said, better integration, improve the SLAs, optimizing the job scheduling. With Yarn, you get a lot more options to do the grouping of the resources. And yeah, I don't think we get the full out of that yet. Current setup, Jenkins really nice, but it's a single point of failure. If that node goes down, then we are in trouble. And we have some other workloads around natural language processing and image recognition that are now on separate pipelines. But with Yarn, we could look into moving that to the cluster as well. So that concludes the talk. Are there any questions? Yeah. Do we have a mic, by the way?
The data scientists, what did they do before? So have they grown with this new platform, or have they used before other tools, like SAS, for example? And so how was the transformation maybe in this area of tools and knowledge of the people?
The data scientists I mentioned grew with the platform. We still have what you now would call data scientists, but like analysts in like the print division, which do a lot about like best next offers and churn modeling for consumers. They still use SAS or SAS. Yeah.
And this will stay, or shall stay like this, or are there plans to move this to Hadoop as well?
Yeah, that was the integration with other BI environments point. Yeah, we probably will start combining that in the future. There now the data goes already back and forth, so we're getting some data from SES, and we're providing back some of the data from the digital sources, but it's not. Yeah, it's not really streamlined yet. In the ideal world, you would be able to fetch directly from SCS the data on Hadoop, so with like the access to Hadoop connector. But yeah, we don't have that in place, at least not yet.
Hi, could you describe how you bring in a new data source in with the ETL and getting it into Hive?
Yeah. What we let's say we need to get the weather data from the National Weather Service, which is on a HTTP location. It emits a CSV file. So we would create a new project in or a new directory in the repository for the ETL. We would create a new Jython script. We have some framework there in place to take care of some of the functionality, but effectively we would there call the HTTP location, download the file, move the file to Hadoop, to HDFS, and then that job is done. Then we have like a second job that will look into the HDFS directory. If there's a file, it will do a transformation of that file to the Hive staging first. So what it will do create table on external file in Hive. So that will map the external Hive table on that CSV file. So you will be able to query it, but it will be suboptimal. And from there, we do a select into STEM, NL, weather data table, where if it's easy, we do select star, and otherwise we like do some of the changes there, and do the in-place copy, and then we're done.
So I guess I was wondering who actually performs the transformations from source raw data into normalized data.
The team of 3 does that. So they first would deliver the extraction script, getting it on the cluster. Then already data science could start using it. But then as like a second step, they provide it in the Hive structure so that also the business analyst can use it.
Thank you very much. Great session. On your roadmap, you mentioned the image recognition. Could you elaborate what is the vision of the additional source in image recognition service? And the second question, do you plan to implement any showback to those consumers of the data? Thank you.
The image recognition, we use a proprietary tool which was a spin-off from the University of Amsterdam. It's called youve. It's been recently acquired by Qualcomm. And now it's not available anymore. It's become a research project for Qualcomm. So that's also why we're looking into other alternatives for running that workload on Hadoop. What we do with it, we have like this content repository where editors and also users can search for content, and usually a picture of a strawberry is not called strawberry.jpg, it's called abc12345.jpg, and it contains only silly metadata about the Photoshop version. But what we can do is, looking at the picture, say, hey, this is strawberry, and then add that to the search engine. We're using Solar. So then when you search for strawberry, you're getting like strawberry pictures. Did that answer the second question?
Thank you. And the second question is, do you plan to implement any showback to the consumers of your service downstream to all those analysts submitting queries?
Yeah, for instance, if you go to nu.nl, the homepage, there's like a blog with like the most read articles. So that's like the simplest form of the way we provide data back. Also, if you go there to the entertainment section twice, and then you go to JavaScript and look at what cookies have been set, then you will also find something. So that's that's how we provide the data back. We don't have a real like data providing service for consumers.
What I meant internal consumers, those marketing other people internally at the organization.
Yeah. Then I don't understand the question.
Okay, so the question is for those people that consume the outcomes of the analysis, like they want to correlate the weather data with some additional statistics. They submit the queries. These queries take time. They take compute time. They take data. Yeah. Do you plan to charge or show back which division, which analyst internally consumed all those resources? That was the question.
Yeah. So currently we don't, because we really want to increase the usage of the entire platform, because we really feel this powers like the next generation of solution, and we really want to get the data in as much hands as possible. We do have like a dashboard that shows like the data that's being consumed and the queries that are being run, and that gives us a way. I think it was on the roadmap on the future slides. Gives like the team the option to provide feedback to the business users, because usually they run without a where clause. And that's really cool in your MySQL or SQL database with like 2 million records, but we don't consider that to be really cool on a 30 terabyte data set, because you're burning a lot of CO2 to get the data, whereas you would do the where on a partition. It would limit the time it runs. And nowadays, the users really are noticing that their query is getting slower. But when we started out, and there were less users, so there were only 5 users on the platform, they didn't really notice if they were streaming through 30 terabytes or only 3, because the query would take a amount of time, but it didn't dramatically increase. But chargeback in the future, maybe. The final question before time is up, here in the second row. You have to stay here forever anyway, because there's no way of finding your way back to the main hall.
I never heard of Jenkins being used in a Hadoop area for this kind of workload. Could you please tell a bit more about the rough edges with that? Because we're currently looking into a new workflow scheduler.
Okay. There are some simpler, more Hadoop-oriented alternatives. So Luigi from Spotify and Azkaban from LinkedIn. So I would also consider looking into that. I think 2 rows back is one of the developers, so you should ask him for the nitty-gritty. It works pretty well. Issues we're having is with like the update frequency. We're running an unsupported version. Maybe with a support version, it's better. But the upgrades, well, you have to test them thoroughly, because the stuff breaks, and it's coming quite rapidly. And there's also like some security fixes, so that we definitely want to run as fast as possible. The redundancy is an issue. Since it's being a build server, it's not really designed for full tolerancy, because if the build server is down for an hour, who cares? But since we're running it at such a critical point of the infrastructure, the high availability is a much bigger issue. The commercial version offers, somewhat of a high availability setup. The version we're running does not. There are ways to get around that by separating out like the executors, that's not trivial. That takes some engineering. And I'm looking at the developer. Is there some really important thing I should mention?
You were mentioning how we use Jenkins. So to parse really large files, sometimes it's something as simple as launching a Hadoop streaming job to trigger something on the Hadoop cluster. It's already quite a big help.
Yeah, that's true. So the bigger tasks, that's I'm sorry, I was bashing Uzi before. The nice thing about Uzi is that runs as like a native ETL job on the cluster. So that will give you the parallelization you already need. With Jenkins, you have to fake that in a way that Thelma just described. Niels?
I know that nowadays you can run Jenkins on a Mesos cluster, so that may be an idea to try out. But you chose this at the time as the best choice. Would you have made the same choice for Jenkins today? And if not, what would you have chosen most likely?
I would more deeply consider Luigi and Azkaban. I think their maturity is not that high yet, but they're like more built for this purpose instead of Jenkins. It's kind of a weird use case. So yeah, since the team consists out of developers, they're used to working with like Jenkins. Which is for the rest of the development stuff, we're moving to Bamboo, so we're getting rid of Jenkins in some other cases. But for big data, we're still using it. For Jython, I really like it, and I was able to develop Python. I'm not a really good Java developer. The team now has some better Java developers. I'm with the Lambda architecture and the fact that you have to now we have to distinct between what's going into the real-time or in the speed layer compared to what goes into the batch layer. It's not causing us that much pain yet, but I see in the future that having there a common code base and now also the projects that really can benefit from that code base. I see that as a downside of the current solution. I think time is up then. Otherwise, come talk to me or one of the other guys from the team. And I hope you enjoyed the session. So, thanks.